Welcome back to the topic of binomial theorem. Today we're going to learn how to find coefficient of specific terms. We do so by using the general term. Okay? So what exactly is a general term? It is an algebraic expression that allows you to find a specific term in the binomial expansion without doing the full expansion. So for example, if I just want the coefficient of the x to the power 4 term, I can find it without doing a full expansion because a full expansion may take very long, right? So in this formula, you have tr plus 1 equals to n choose r, a to the power n minus r, b to the power r. Let's talk a little bit about this. Now, why is it tr plus 1? Firstly, if you look at bracket a plus b to the power 2, how many terms are there in this expression when you expand it out? You got a squared plus 2ab plus b squared, right? So there are 3 terms when the power is 2. And therefore, when the power is 3, you have 4 terms. And if the power is 4, you should have 5 terms. All right, so there's always one more term than the power of the binomial. So we always put t, r plus 1. And n choose r, we'll talk about that later. Now, as in our expansion, the power of the second term always follows this r here. So it comes up here. And the power over here is n minus this, so n minus r. Okay, now, but what exactly again is a general term? I think you have come across this concept in Sec 1 when you did number pattern. So for example, like if I give you a number sequence, 5, 8, 11, 14, 17. And then they ask you, what's the general term? I think in Sec 1, they can also call this the nth term, right? So, there's one method where you use a formula because you can see that there's a common difference. So if there's a common difference, you can actually use this formula where the nth term or general term is a plus d n minus 1, a being the first term, and d being the common difference, which is 3. And now you expand out, equals to 3n plus 2, right? So this is my general term. What do I mean by that? This algebraic expression 3n plus 2 represents this number sequence. For example, if I want the second term, I'll just sub 2 into the n. 6 plus 2 is 8. And you can take a look, the second term is 8. Okay, let's try the fourth term. 3, 4 plus 2 is 12 plus 2, which is 14. And there you go, you have 14. So a general term is an algebraic expression which allows you to find a specific term. Okay, it is the same in number pattern, it is the same in binomial theorem. So let's go to the first example. So example 1. In the expansion of 2 plus 3x to the power 8, find the 8th term in ascending power of x, the coefficient of x cubed, and the middle term. Okay, so let's start with not even part A. Let's start with the general term. T r plus 1 equals to 8, choose r. 8 is the power, choose r. First term, second term. And now this r comes up here. And then this is 8 minus r. Okay, so this is my general term that represents the expansion of 2 plus 3x to the power 8. So let's proceed with part A. I want the 8th term. Very simple. If I want an 8th term, I put T8. But what's R in this case? R plus 1 is 8. So actually R is 7. Okay, so 8, choose 7. Actually, I can just write here, therefore, R equals to 7. 8, choose 7, 2, 3x. So this R becomes 7, and this 8 minus 7, which is 1. So if I do 8, choose 7, it's 8, 2, and 3x to the power 7. And let's simplify this. 8 times 2 times 3 to the power 7. I get 34992 x to the power 7. And this is my nth term, right? My 8th term. Okay? Now, how about the coefficient of x cubed? Now it gets slightly more complicated, but it's still simple. So I do not know which term is it, but I know that the power of x is 3, right? So what am I going to do? Can you see my x is here? That means I need this to be power 3. So r is simply 3. So if r is 3, what's my term here? What's my term here? R plus 1, right? So t, term 4. So right now, I'm going to put all my r as 3. 8, choose 3. I'm looking back here. This is my general term. 8, choose 3. 2, 3x. So this 3 comes up to the power of the second term, and 8 minus 3 is 5. So 8 choose 3 is 56. 2 to the power 5 is 32. And this is 27x cubed, right? So let's simplify this. 56 times 32 times 27. I get 48384 x cubed. There you go. Actually, no. They asked for the coefficient, right? Therefore, coefficient of x cubed equals to 48384. All right. C, middle term. Now, what is a middle term? Remember just now I said that for a binomial with power 8, there's always one more term, right? So there are actually 9 terms in total when you expand it. So what's the middle term of 9 terms? Middle term will be 9 plus 1 divided by 2, which is 10 over 2, which is the 5th term. Okay, so the middle of 9 terms is 5th. Now, I just have to find the 5th term then. Okay, but so looking back at the general term, if my term is 5, r plus 1 equals to 5, r must be equals to 5 minus 1 is 4. So my r is 4, 8 choose 4, first term, second term. Power comes up here, 4, and 8 minus 4 is 4. So 8 choose 4, I'll get 70. 2 to the power 4 is 16. 3 to the power 4 is 81. And let's simplify. 70 times 16 times 81. I'll get 90720 x to the power 4. Okay, and there you go. I've showed you how I can use a general term. The general term being this over here to successfully find specific terms in the binomial expansion without actually doing the full expansion. Okay, so moving on. Example 2. Find the coefficient of 1 over x to the power 21 term in the expansion of x minus 2 over x squared to the power 12. Okay, so firstly, I want you to know that this, if you have learned indices, is actually x to the power negative 21, right? Why is this important? Because I'm going to do the general term out and you'll find out why. So general term, tr plus 1 equals to power 12. So 12r x minus 2 over x squared. R comes up to the power here of the second term, and here is 12 minus r. Okay, but the problem is if I want my x to be power negative 21, I cannot have an x in the first term and an x in the second term. I need to somehow join these two up. So how do I do that? The first thing is I need to separate this second term out. 12 choose r, x to the power 12 minus r. Now, I want my x alone. I don't want a negative with it, so I'll keep the negative with the 2. And this is r. And this is x to the power negative 2r. Okay, because the x squared is in the denominator. All right, now using your rules of indices, what is x to the power 12 minus r times x to the power minus 2r? It should be x to the power 12 minus 3r. Because if you remember your laws of indices, x squared times x cubed, you add the power, right? So it's equals to x to the power 5. So you're actually adding 12 minus r plus the negative 2r. So it's 12 minus 3r. And then you get the last part is negative 2 to the power r. So this second step here is very crucial. You need to be able to split this up to separate out the x so you can join the x together. Okay, so now that I have got my general term, which is this, I'm no longer referring to the first step, I'm referring to the final general term. Okay, find the coefficient of x to the power minus 21. So, can you see my x here? This is my power, 12 minus 3r in my general term. I'm going to equate it to negative 21 because I want to find out what is my r. That's the main goal here. So if I shift it over, 3r equals to 12 plus 21. Okay, I will get 33 and r equals to 11. So now that I know r is 11, I'm going to put it back into my general term. If r is 11, I'm finding my 12th term because r plus 1, right? So now looking here, 12, choose 11, x to the power 12 minus 33, which is negative 21. If you're not getting negative 21, something is wrong, okay? Because that's what exactly we're finding. And negative 2 to the power 11. So let's work it out. 12 choose 11 is 12. And let's put this x to the power 21 and minus 2 to the power 11 is times my negative 2048. So simplify this. I get negative 24576 over x to the power 21. Okay, but again, they did not ask for the term, they asked for the coefficient. Therefore, coefficient of x to the power negative 21, or maybe 1 over x to the power 21 is negative 24576. All right. So obviously example 2 is already slightly more difficult than example 1 because you need to separate out the x. When do you need to separate out the x and join them together? When you see x and x in the first term and the second term. Okay. So now let's go to the third example. I'll show you similar kind, okay? Example 3. In the binomial expansion of x squared plus k over x power 6, where k is a positive constant, the x-independent term is 1215. Find k. So slightly different type of question, but still the same method, okay? But firstly, what is an x-independent term? An x-independent term is a term which is independent of x. That means it does not have an x. So how? That means the x is actually to the power 0, meaning we are finding a constant. That means the power of x is 0. Okay, so how are we going to go about doing this? Again, general term. 6, choose R, first term, second term. Again, do you see that there are x and x in the first and second term? So this will be R, this will be 6 minus R. Again, I need to separate the x out from here and join it with the x in the first term. So 6 choose R. I can actually start expanding the powers here. So it's 12 minus 2R. And now I'm going to separate this. It's actually k to the power R and x to the power negative R because the x was in the denominator. So it's actually x to the power minus 1. So x to the power minus 1 times R is x to the power minus R. And now I can join these two x up again by rules of indices. 6 choose R, x to the power 12 minus 3R, k to the power R. And there you go, that is my general term. So I said the question said you want an x independent term, right? X independent term, x is actually power 0. So this 12 minus 3R, I'm going to say that it's equals to 0. So I solve it, 3R equals to 12, R equals to 4. All right, so if R is 4, according to my general term, it will be the fifth term because TR plus 1. Fifth term, 6 choose 4, x to the power 12 minus 12 is 0, which is good because we are actually finding the x independent term, and k to the power 4. Okay, I won't know what's k. I'm going to solve it when I equate this to 1215. So what's 6 choose 4? 15. 15 k to the power 4. X to the power 0 is 1, so I'm not going to write it in. So therefore, they say the x independent term is this, and this is the same as this, right? So I'm going to equate them together. 15k to the power 4 equals to 1215. K to the power 4 is actually 1215 divided by 15. I get 81. And therefore, k is a quarter root of 81. You should get 3 or minus 3, right? Because there are always two answers. But didn't they say positive? So I'm going to reject this negative 3. And therefore, k equals to 3 is my answer. Okay? So, again, I've shown you how to find a specific term, in this case, the x-independent term, without doing a full binomial expansion. All right, so the general term is actually very useful for many questions in binomial theorem. So, key points to note. If there are two terms containing x in the binomial, separate them out from their coefficients and join them up using the laws of indices. You could see this in example 2 and 3. Okay, now, so a binomial with power 5 will have a total of 6 terms. A binomial with power 7 will have a total of 8 terms. Therefore, the middle term of a binomial with power 8, 8 means there are 9 terms, right? So what's the middle of 9 terms? 9 plus 1 divided by 2, you get the fifth term. Okay, and lastly, an x-independent term refers to the constant or the term containing x to the power 0. Okay, that's why it's called x-independent. It's independent of x. All right, so hope you learned something from today's lesson. If you find my video useful, please give my video a like and subscribe to my channel for future content. All right, thank you very much.